This is lecture video 47, and in this lecture I will explain how to eliminate square roots inside integrals consisting of trigonometric functions. So look at this example. We don't know any techniques yet to directly evaluate this integrand function here. Instead, we can try to rewrite it. For example, you need to remember half angle formulas here. So sine square x is written cosine 2x over 2, and there is a similar formula for cosine square x. The only difference is this plus minus sign in the middle. Okay, so 1 plus cosine 4x. Is there a way to rewrite this function by using this formula in terms of cosine square function? So look at this part, please. Instead of 2x, you have 4x, right? And you know that what angle you write here, you double that angle on the right-hand side of the formula. That's why you need to have 2x here to have 1 plus cosine 4x on the right-hand side. Okay, this is the same formula written for the case where you have 2x instead of x. Okay, then you see that 1 plus cosine 4x is written as cosine square 2 times cosine square 2x, right? Like this, so you just multiply these two. And then this integral is from 0 to pi over 4 square root 2 times cosine square 2x dx. Okay, you can take this square root 2 constant out from the integral as it is a constant, like this. And then you can simplify this square and the square root. It is possible, but you need to put this absolute sign for cosine 2x function. Okay, like that. And now we want to evaluate this function. First of all, you need to get rid of the absolute sign to evaluate it. With the absolute sign, you cannot start evaluating. So how to get rid of the absolute sign here? I'm sorry, this was pi over 4. I fix it. Okay, you need to understand the sign of the function inside your absolute signs, right? So let's draw the unit circle to understand what sign this function has. So we are dealing with the cosine 2x function, right? And consider cosine function. Cosine function gets positive values over here from 0 to pi over 2, cosine function always gets positive values. That's why then, okay, let's emphasize it one more. From here to here, cosine takes positive values, so let's write this down. If this is between, x is between 0 to pi over 4, 2x will be between 0 to pi over 2, right? So it will be in this portion of the unit circle. And so that's why cosine 2x will all be positive, because 2x is between these two angles, and we know that from 0 to pi over 2, cosine function gets positive values. That's why this is the interval for x for cosine 2x function to have positive values. Okay. So let me write this down. This is always positive on positive 4, x is between 0 and pi over 4, just like we showed here. That's why this sign is positive. So I can just directly remove the absolute sign safely, because I proved that cosine 2x gets always positive values for x lying between 0 to pi over 4, which is the interval of integration. So I remove the absolute sign safely without doing anything like this. And there was this square root 2 in front, and then you can just write the result. So I am trying to evaluate the integral of cosine 2x. It is evaluated as sine 2x over 2, and then I will insert upper lower boundaries of the integral. So the result is, if you insert pi over 4 to your integral, so just insert upper boundary, pi over 4 multiplied with 2 is pi over 2 minus, you just insert 0. Okay, what is sine pi over 2? It is 1. And what is sine 0? This is 1, and sine 0 is 0. So the result is given as just square root 2 over 2. Okay, this will be a short video. Thank you for your attention.